Hello everyone. We have a question which says that a curve has equation y is equals to x square minus x plus 3 and a line has equation y is equals to 3x plus a. So basically we have equation of curve and equation of line. According to the first part of the equation, show that the x coordinate of the point of intersection of the line and the curve are given by this. So basically they are talking about the point of intersection, that means common point, and for the common point we simply make the equation of the curve equal to equation of line. So we have done over here, this is the equation of the curve equal to equation of line, and after that just rearrange them, x square over here minus x over here, place this 3x over here to make it negative 3x, 3 over here positive, and this a would come up over here with negative 3, and finally resimplifying it, and this would become x square minus x minus 3x is minus 4x, and constant is 3 minus a inside the bracket as per the first part of the question. We are done with that. According to the second part of the question, for the case where the line intersect the curve at 2 points, it is given that the x coordinate of one of the point of intersection is -1. So basically the curve and the line are intersecting at 2 points. They have given us the x coordinate of one of the point of intersection, which is -1. So basically the value of x is -1, and this value of x is the x coordinate of the point of intersection, one of the point of intersection. Find the x coordinate of the other point of intersection. They have clearly mentioned in the statement that 2 points. That means if it is 2 point, so no problem, we could easily find that, because they have given us a clue that one of the x coordinate is -1. Just place that -1 in the equation that we made in the first part, because point of intersection means common, and the equation that we have made in the first part is based on point of intersection. So just place the value of x as -1 over here so that we could get the value of a. And we did the same. We took x as -1, place at the place of x, and after that simplified the brackets, and finally we got the value of a as 8. After getting this value of 8, place it again in the equation over here, 3 minus a, make it 3 minus 8, and 3 minus 8, and finally we have got a proper quadratic equation. The question said that find the x coordinate of the other point of intersection, because it is a quadratic equation. If we use a quadratic formula, definitely we will get 2 x coordinate, and one x coordinate is -1, definitely it was given, and whatever the other is basically the answer for the second part. So if we just go for a quadratic formula, take the value of a as -1, the value of b as -4, the value of c as -5, and place it in the quadratic equation and simplify the quadratic equation, we can see that we got two values of x is equals to 5 and -1. This -1 was given in the question, and that means this 5 is basically the x coordinate which was asked in the question, that find the x coordinate of the other point of intersection. That means this x is equals to 5 is the answer for the b part. For the third part, it says that for the case where the line is a tangent to the curve at the point P, tangent to the curve, that means this time they are giving us a condition that they are tangent, and definitely when it is a tangent we know that the discriminant is equal to 0. The question says that find the value of a and the coordinates of P. What is P? P is the intersection point where the tangent is being made. So just consider the same equation that we made in the first part. Just take the same equation over here, because definitely that equation that we made was based on the intersection point. just take that equation, but this time the condition is tangent, so we would be using the discriminant b square minus 4ac and placing the value of a as 1, b as negative 4, c as 3 minus a, placing it in this discriminant, and after placing these value of a, b, c, finally we got the value of a as negative 1. According to the question, find the value of a and the coordinates of p. Because now we have found the value of a, which is negative 1, again place this value of a in the equation over here, 3 minus, and again the value of a is negative 1. As you can see, 3 minus, again the value of a is negative 1, simplifying it, and again we have got a proper quadratic equation. Keep in mind, this equation is an equation which is definitely based on a tangent condition. So now if we go for again using a quadratic formula and use the value of a, b, c as 1, negative 4 and positive 4, as you can see we got a 0 over here for this particular root. Because it was a tangent, definitely it would be 0. So finally we have got the x coordinate, which is 2. Because they are asking us to find the coordinate of p, definitely we need the y coordinate also. We had just found the x coordinate, so use the same equation. Which equation? Sorry, you can go for any equation, whether it is the equation of the line or the equation of the curve. For example, if you go for using the equation of the curve, y is equals to x square minus x plus 3, use it, place the value of x as 2 over here, get the value of 5, so which is 5. So 2 comma 5 is basically the coordinates of p for the given third part of the question.